We are in PF57 part 3.3, that is the last section of the vulnerability and also ending the 57 section. So how to protect bearer tokens at the protected resource. So let's see. The protected resource often handles access token in a way similar to that of the authorization server and should be treated with the same care for security. Since there are likely to be more protected resources than authorization server on the network, perhaps even more direct care should be given. When you use bearer tokens for security, like a way to prove someone's identity, there is a risk that someone with a bad intention could steal and reuse those tokens to access other protected resources. Also, sometimes the token can accidentally appear in system logs, and these logs track everything that happens on your system. If the log captures all the web traffic, like incoming requests, the token might end up in those logs. This is a problem because a malicious person could find the token there and use it for their own gain. So it's really important to make sure tokens are removed from logs or scrubbed and so they can't be misused. Right? So that's the risk we see with the bad intentions. So that's why I think we just discussed in the previous section also, right? We are not supposed to keep the token in the logs, or we need to make sure that it's removed from the logs or scrubbed and cannot be misused. Yeah. A resource endpoint should be designed to limit token scope, respecting the collection minimization principle and asking only for the minimum set of scopes needed to handle a particular job. Although it is a client that requests the scope associated with the token, designers of a protected resource can protect the ecosystem by requiring tokens with only the most specific set of scopes possible for functionality. This part of the design process partitions the application resources in logical way such that a client won't need to ask them for more functionality than necessary in order to do its job. So yeah, we're just trying to limit, I think, again we discussed in the previous section, we're trying to limit the scope. And also the protected resource is designed in that way only. The resource server should also properly validate the token and avoid the use of a special purpose access token that have some sort of superpower. So protected resource has to avoid also few things, like as we are saying, special purpose access token that have some sort of superpower. So the resource server is not supposed to allow that. And also it has to validate the access token. That means the client has sent me an access token, but I need to see who issued this token, right? And whether it's valid or not. So I'll just go back to the to the authorization server. That's the introspection call we have seen in our practical session in OAuth IDC. So I'll go back again to the from resource server. I'll go to where to authorization server to do the validation of my token. That's the introspection call. Although it is common for a protected resource to cache the current status of a token, specifically when using a protocol such as token introspection, the protected resource must always weigh the benefits and drawback of such a cache. It's also a good idea to use rate limiting and other techniques to protect the API, which help prevent attackers from fishing for valid tokens at the protected resource. Right? So we just need to implement at the resource server that this part, like rate limiting and other techniques to protect the API. Okay, storing access token in transient memory instead of the permanent storage can help protect against attacks on the server where your data is stored. If the tokens are kept in temporary memory, it's harder for attackers to find and steal them, even if they manage to attack the server. However, the downside is that attacker might still be able to get to the data you are trying to protect. So you have to weigh the pros and cons both. Essentially, it's about deciding whether the extra protection of temporary memory is worth it, considering the potential risk. Right? So again, we have the pros and cons, but yeah, it's good to store the token in the transient memory. So in somehow, if it gain access also, yeah, it's not like attacker will not be able to do much thing, right? Because that token will go away automatically in some time. But yeah, we have some drawback also that, like, yeah, in terms of the protecting that transient memory part, right? Whether to decide extra protection for transient memory is worth it or not. So yeah, based on that, it's again the calculating the risk part, right? So in this all vulnerability section, I think it's going to end. I think this is last one. Yeah. So we basically covered 54, 55, 56, 57, right? These are 4 sections we covered. Like, so we talked about common OAuth client vulnerability, where we mainly talk about the referrer part and the referrer part, like to how to hijack the authorization code. Then we just talked about the access token leakage, right, through the open redirector. So all those things we discussed. Then we just talked about the in the 55 we talked about this one, like yeah, like the common protected resource vulnerability, right? How we are what are the practical implementation we can use to protect the resource server from vulnerability. Then in the third section we talk about the authorization server, right? What are the practical implementation we can do to protect the uh, my authorization server in OAuth. Then in the fourth section we talked about like the bearer token part. What is bearer token and how we can protect it, like from getting vulnerable. So these all are the practical implementation we talked. So we can just try to whenever we are designing solution, we can just try to put all those things so that we can just minimize the risk. But again, the risk is there. So the better thing is what I see, that is the monitoring part. You can design the solution whatever you want, right? That is definitely required. Whatever the prerequisites are there, you can go and build the solution using that, so that you can minimize the risk, whatever, like as per the standard. But continuously monitoring is very very important to reduce this risk and this vulnerability. And how we can do that? So you can just think about some alerts part, right, in your mailbox. You can just maybe you have some operation team in the industry, right? So just tell them to continuously monitoring the services. Like maybe you have some graphs, right? Maybe you can build some dashboard in Kibana or Splunk and just see the behavior of your services, right, in terms of everything, right, in terms of the OAuth OpenID Connect, in terms of SAML connection, in terms of the performance. It's not only on the OAuth OpenID Connect, right? The vulnerability can come from anywhere to your system. So you just need to ensure that, yeah, those all things are continuously monitored, and if there is any alarm, if there is any difference we see, we need to raise a flag and start the investigation ASAP before it become a major issue. And yeah, in generally industry, this is followed already, but yeah, just for your understanding, I'm just saying. So yeah, this is the important part. One thing, design the solution with the knowledge what we have in the vulnerability section, and the second thing, just do the monitoring 24/7 with some automation, with some program which can just alarm us if there is any difference we see in terms of anything, in terms of performance response time, in terms of the reuse of the authorization code, or in terms of the leakage of the access token, or anywhere, right? It can just quickly alarm us, and then we can just try to see what happened, right? So I hope you understand. This is just a more theoretical part what I see, but yeah, just for your understanding. And now from the next section, we'll just again start with the practical implementation. So I'll just talk on the REST APIs. So we have in Ping Federate, there are multiple REST APIs, right, through which you can just no need to go to console. You can directly call them and just do your work. So we'll just try to see that how we can call those using in Java, and we'll just try to cover maybe 6-7 examples, and we'll see that rather going to console, how I can just call that from my Java program, and then I can just fulfill the work. Okay, so let's see from the next section. And if you have any questions on the vulnerability section, please put, so I'll see that if I can able to answer, or maybe we can just discuss in another session. Thank you.